Before we actually start the vocab for the examples for this section, I want to review real quick how to graph dots or graph points on a coordinate plane. And I know it's something you've done before, so I want to make sure you remember how to do it. First off, remember this is the x-axis, this is the y-axis, in the middle that's at point 0, 0, the origin. As a reminder, when you go this direction on x, it's positive. This way is negative, right? So positive and negative. And when I go this way, when I go up on y, that's positive. And when I go down on the y, that's negative. Now, as far as graphing goes, you'll be given an ordered pair. Something like 2, 4. And what that means, you start at the origin, and the first number is the x, and we're going to go positive, 1, 2. And then we'd go up for the y, because that's positive, 1, 2, 3, 4, and put a dot right there. Okay? So, again, remembering that the first item is our x, and the second one is the y in our pair. So let's figure out where some of these other things are and write them in there. So for instance, start with this dot right here. That's 1, 2, 3, 4 to the right. So that's going to be 4, because that's the x. And then it goes up 1, right? So 1 for the y. So 4, 1. This point down here, you're going to go 1 to the right. So that's positive. And then, once you've done that, you go down 2. So that's going to be a negative 2 for the y. This point down here, you're going to go 1, 2, 3 to the right. To the left rather, I'm sorry, so that's negative 3 for the x. And then you went down 1, 2, 3, 4. So negative 4 for the y. Then this point up here, you're going again, switch colors here, 2 to the left, so it's negative 2 for the x. And then the up is 1, 2, 3, 4, so positive 4. Okay, so just a quick review on how to graph. Now the way dilations work, I'm going to have to give you some information before you can even begin to do them. So, I will give you an image like this, A, B, C. And currently it's 16 from A to C, 8 from C to B, and 12 from B back to A. Now, when we go ahead and perform the dilation, I have to give you what's called a center. That means everything in this case, by the way, it's going to shrink, is going to shrink to A. That center never moves. It gets rewritten, reused. Scale factor also tells us what's going to change. If it's less than 1, it's going to get smaller. If this number is bigger than 1, it would get larger. This one's actually going to get smaller. So the idea here is that I'm going to shrink down to the A because A is the center. And remember we talked in the vocab about prime. So A shrinks down to A prime, which doesn't technically move, right? Same place. C shrinks halfway down because it's a scale factor of 1/2. So it's going to shrink halfway down this. So it's going to be from here to here will be 8. And that becomes C prime. A to B. It's currently 12. It's going to shrink down to 6. So half its length. And we're going to call that point B prime, and then we're just going to go ahead and connect the dots. The idea is that these angles, notice it's angled like that, do stay the same. It's the same shape, just shrunken down. And you can see they actually did the work here. This went from 16 down to 8. Here from A to B, so A prime to B prime is half of that 6. And then you just connect the dots to finish up. Pause here, go to class kick, and you work one. Okay, so here is your first quick check, and I went ahead and graphed it for you already. Points D, E, and F. So again, D down here, E, and then F. So double check your graphing before you start. And so this time it says we have a center of D. Again, that means D doesn't move. So D is automatically, before you even go any farther, relabel it as D prime. Now we're going to move everything. Scale factor 2. That means we double everything going out from D. So currently, from D to F is 2. Well, scale factor 2, double that means it goes out to 4. So, it's 3, not 4. Apparently I can't count. And you don't count the intersections. Rather, you count the spaces in between. So again, currently it's 1, 2, 3. Anybody count with me there? Again, I'm going to start at D. I'm going to go 1, 2, 3. Kind of like you're hopping across between them. So one more time, 1, 2, 3. So scale factor 2 means I double it. 1, 2, 3, 4, 5, 6. And I'll put a dot down here at our new F prime, right down here. And again, you call that point F prime. And now currently, so I just worked my way around the shape, by the way. So you would start here and basically work your way around. Don't try to do the diagonal. Those are sometimes kind of tough to count. Currently from F to E, it's 1, 2, 3. So again, doubling that makes it 6. So I'm going to count from, and again, you go from F prime out. You don't start at F. 1, 2, 3, 4, 5, 6. So it'll land down here. 1, 2, 3, 1, 2, 3, 4, 5, 6 down here. And that becomes E prime. And you just go ahead and play connect the dots then with your new dots. And you'll find that your angles should remain the same the whole way across. And there we go, there's your new shape. And again, centered at D, and you expanded each of your others. And remember, when you mark the new ones, you mark them with the prime mark so that we know that's the new shape. So continue here for more examples. On this example, we have center of A, scale factor of 1/2. So again, that scale factor is smaller than 1, so it's going to get smaller. The shape is going to shrink. It's going to shrink to A, so everything's going to be brought up this way towards A. Now the first thing I always do is whatever the center is, I go ahead and relabel that as prime. So that becomes A prime, same spot, doesn't actually move. Then we need to count. Along this left side here, we have 1, 2, 3, 4, 5, 6, 7, 8. And again, we don't count the dots, we count the spaces between them. There are 8 spaces between them. Half of 8 is 4. So expanding out, or shrinking rather, towards A, we go 1, 2, 3, 4. So right here, we're going to move and put D prime. Now you work your way around the shape. Don't start trying to move things weird over here. So I went A to D. We're going to go D to C. So currently from D to C, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, half of 12 is 6. So we're going to put a dot following straight along. Now here's the thing. Straight along here, not along this line. You're going to put it down here somewhere because it's got to keep the same shape. It's not going to go down to here and up and around. So going out 6 from here. 1, 2, let me count here. 1, 2, 3, 4, 5, 6. Right here, we're going to have C prime. I'm going to go ahead and start connecting lines as I go. Now then, it'd be tough to follow this diagonal up along here from C to B. So I'm going to go straight out from A to B. Straight lines are always easier to follow. And again, counting the spaces. 1, 2, 3, 4, 5, 6, 7. Let's make sure we count that right. 1, 2, 3, 4, 5, 6, 7. Half of 7 is 3.5. So right here is going to become B prime. And we play connect the dots. Now the great thing is when we're done, the angle along this line, so along here, should match this angle. And it looks like it does. So that's important. So the whole thing, center of A, scale factor 1/2, it shrunk it right up this way. Pause and go into class kick, and you work one. Okay, on this one we've got a center of J and a scale factor 3. So again, scale factor is bigger than 1, so it's going to get larger. And make sure, again, it's going to maintain its same shape. First thing we're going to do then is, remember, J is the center, so it's not going to actually move, so that becomes J prime. Currently, each of the sides, 1, 2, right? So 3, 4, 5, 6. So we're going to make them 6. We're going to triple them here. So we've got, 2, 4, 6 up here then is going to be K prime. From J to M is 2, so tripling that makes that 6. So 2, 4, 6 over here becomes M prime. Again, a little bit of connecting the dots so far. And then we can go straight out from K to L. That's 2, so we're going to make it 6. 2, 4, 6. It becomes L prime. And we just play connect the dots. And there we go, centered at J, scale factor of 3. Keep watching for another example. Now this shape here, it says figure TRSV shows the outline of a park. The city planner dilates the figure to show the area for the park. It can be used for concerts, so the smaller area. Find the scale factor. It's an enlargement or reduction. So, first off, we got to decide if it gets smaller or bigger. Notice that the original shape, the TRSV, is definitely bigger because the prime goes with the smaller ones here. Remember? So the prime's always the second image, and it got smaller. So that means when I decide my scale factor, I'm going to have a fraction, obviously, and it's going to be smaller than 1. And the way this goes, it's pretty straightforward stuff. You pick one of the original sides, and that matches up with another side. So this goes from, let's count, again, don't count a diagonal one. Let's count this one here from R to S. 1, 2, 3, 4, 5, 6, 7, 8. Now, since I know that this thing gets smaller, the original goes on the bottom. Now, if it gets bigger, right? If it's bigger, we put the bigger number on the top, but since it gets smaller, the bigger number is going to go on the bottom. Now, again, it's 8 from here to here. So from R prime to S prime is 2, so that becomes 2 over 8, which does reduce to 1/4. Now, you could have done it another way. You could have picked from T to V, 1, 2, 3, 4, so that 4 goes on the bottom, and T prime to V prime is only 1, so 1/4. Same answer, no matter which side that I pick. And again, make sure if it gets smaller that you know you have a fraction for an answer. If it would have gotten bigger, it'd be 4 over 1 if everything was reversed. Go back to class kick. Your turn to work one. Okay, so on this one, it says the blue figure shows the outline of a yard. The black figure is a doghouse. The blue figure is a dilation of the black figure. In other words, the idea is it got bigger, right? So going from the black one up to the blue one, it certainly got larger. So we know this is an enlargement. You can just see that. I mean, there's not a lot of thinking involved there. Now, here's the thing. We note that it's 3 along this side, 6 along just here, not the whole thing. Be careful of that. That means the entire side length here is 9. There's going to be 9 along here. So we had to figure out a scale factor. So it got larger, so the bigger number goes on top. So it's 9, and originally that space along here was 3. So my scale factor is 3 over 1, or 3 is just fine.